Welcome, and thank you for joining this webinar, Advancing Quantum Communication, Role, Impact, and Technical Foundations of Quantum Technologies in 6G and Beyond, prepared by Alpert Research Team. Quantum communication is transitioning from academic theory to strategic infrastructure. This webinar explains how physics, not math, can guarantee trust, and how quantum systems integrate realistically into modern communication networks. So this reliance on individual photons and these hybrid channels, what does this mean for the engineers building our wireless and optical networks?
It means the entire physical layer has to be reinvented. The success of these quantum networks depends completely on state-of-the-art components. We need robust, low-noise, single-photon sources, and maybe even more critically, highly sensitive and reliable detectors.
As we start thinking about large-scale deployment, we have to move beyond these simple point-to-point links. We need a comprehensive, multi-layered network architecture that can manage all these quantum resources right alongside our existing classical infrastructure.
The challenge is getting true end-to-end security in this new hybrid world. The proposed quantum communication architecture is necessarily complex. It's layered, and it's designed to integrate these quantum resources seamlessly. It's really divided into two physical layers and two software layers, which kind of mirrors how we organize classical telecom networks. At the bottom, you have the quantum physical layer. This is where the actual hardware lives. The Q nodes, the single photon sources, the detectors. It handles the physical connections, the signal encryption, the key generation, and that delicate process of entanglement generation. Above that sits the quantum network layer. This layer is responsible for managing the transmission of that entanglement and routing the conventional classical waves. And crucially, this is intended to be managed using software-defined networking, or SDN.
The use of SDN is interesting. That suggests the goal is flexibility and automation, which is critical for any dynamic network.
SDN allows for flexible, on-demand routing and configuration of all the quantum links, whether they're fiber, free space, or even satellite-based.
What about the software or channel layers?
So then we move to the channels themselves. You have the quantum network management and control layer, which is the high-level operational brain, handling all the hardware and software oversight. And below that, you have the quantum link layer. Its job is to perform critical link status monitoring. It uses those error control protocols we talked about earlier, like SSP or SAR04, and it handles flow control using things like COW or DPS to ensure the physical link's integrity.
The message is crystal clear. The integration of quantum systems into our network architecture is happening now, not in some distant theoretical future. We've established that quantum communication will not replace classical wireless networks, but it will redefine how trust, security, and optimization are built into 5G advanced and 6G systems.
Interested in gaining a deeper understanding of the transformative power of wireless technology? Join the Alpert Research Team's webinars to explore cutting-edge wireless innovations, their applications, and their implications. Click the links below to learn more.